So, as part of our understanding for what factors affect kinetic energy in this assignment, you can see there's a guardrail here, and in this picture, you can tell that a car has crashed into it. Now, I decided to go and find a crash test, videos of crash tests. So, I want you to better understand how these occur. So, whenever a car is going to come out to market here in the United States, the company is required to go ahead and send in a whole bunch of nice brand new cars to smash up and to see how the cars react. Now, you can see in the video, I'm not going to play the video because it doesn't turn out too well screen recording it. But I want you to see that each car that's smashed like this reacts a little bit differently. Some are better than others. Now, in this one, you can tell the car gets pretty crumpled. When a car gets into an accident, energy never is created or destroyed. So, just like the law of conservation of mass, or law of conservation of matter, that energy cannot be created or destroyed, we can't create or destroy energy, but we can change it. Now, this car that's moving has kinetic energy. Now, in your assessment, remember that if I ask the question, what is an example of kinetic energy? If you say a car, that's not necessarily true. A car that's moving, a car that's driving, would have kinetic energy, but a car in a parking lot does not when it's not moving. This car right here smashes into the wall. Since energy can't be created or destroyed, energy can only be transferred. Normally, energy would be transferred into the whatever it smashes into. So if you get rear-ended, or if you rear-end somebody in a car, that energy is transferred to the car in front of you. It moves the car in front of you. Now, this block right here, and as you watch the video that's in the other day's assignment, this does not move. So there's two places for the energy to go. One place is into the car, and they actually build in these things called crumple points into your car that are designed to absorb energy. The other place it can go is into the humans inside. It's transferred to whatever's inside of the car. And that's really dangerous because that can cause you to die. When the energy is transferred into you, you can get whiplash. So, they build cars so that they do crumple up. In the safety crash test ratings, you can see how well the car protects the people inside is what it's rated on. It's not rated on how smashed up the car gets, rather how much it protects the person inside. Now you can go through and you can look at all these other crash tests. If you're curious, on the side, in the window right there, you'll notice in some of these tests, let's see if we can find one. We'll play right here. You'll see in the window that an airbag comes out. This is called your side curtain airbag. And if you look behind the guy's head, right beside the windshield, it'll say SRS airbag, or right by the seatbelt thing. So, let's see, is there anything else I want to tell you on this? There's a few other tests they do. Some cars don't handle as well. If you look at the end, the Dodge Challenger did not do well on its safety rating. And you can tell at the end, when they're pulling the dummy out, the dummy's missing a leg. It's not very safe when your car crushes your leg in one of these accidents. So we go on to what factors affect how much kinetic energy an object has. One career that you might want to consider is a car crash investigator. So a car crash investigator could figure out, just looking at the guardrail, how fast a car was going when it hit it. Now sometimes people aren't super honest with how fast they were going when they cause an accident, because that can get you into some pretty big trouble. But it's against the law to drive recklessly. So car crash investigators will come out and they have data on how much that rail will move with a certain amount of mass and velocity. A certain amount of kinetic energy will cause that guardrail to move a certain amount. So they can actually take the amount of data, knowing the car that crashed into it, they can take the mass of that and figure out how fast it was going in order to cause a certain amount of damage. because things with more energy cause more damage. Now let's look for some patterns here. This first question right here asks for patterns looking at between mass and kinetic energy. If we look right here, we can see I made these numbers easy for you guys. We have 920 and 1840. Notice how a smart car is just like one of those little tiny cars. It's not a Tesla. It's like a little tiny car. You can Google it if you want to. But I just doubled the mass here. These aren't the exact masses. Corvette is double what a smart car is in mass, and a U-Haul truck, a big old moving truck, is going to be double the mass of a Corvette. In real life, it's slightly different, but they're all going the same speed in this data table. You'll notice right here the amount of kinetic energy. As we doubled the amount of the Corvette to the U-Haul, we also doubled the amount of kinetic energy. That pattern holds through. Whenever you double the amount of mass, you always double the amount of kinetic energy. So that's going to be what you're going to want to talk about here. There is a proportional relationship between that. Now, if we look at the speed, I just took this speed right here, 13.4. If we double the speed here, and then I take that speed and I double it again. If we look at the Corvette, the kinetic energy is 165.2 kilojoules. Now, if we look at this, 13.4 to 26.8, I doubled it. So if speed has the same effect on kinetic energy, then we should see the kinetic energy double as well. But wait, if you look right here, 165.2 to 660.8, it doesn't double. It actually goes 4 times the amount. And then this number right here, times 4, goes to 2643. So, if I go online and I type in kinetic energy equation, Ke equals 1/2 mv squared. Let's take a look at this right here. So if I double the mass, it would make sense in this equation that I would double kinetic energy. If I double velocity, that is double squared. So 2 squared is 4. So if I come back, this is 4 times the amount. So whatever change you have in velocity, that change is squared, meaning that velocity is so much more important. So if I were to give an example, if you were a demolition company and you needed to either invest in a new, bigger, more massive wrecking ball to take down a building, or invest in a new crane that could move that wrecking ball faster, you would want to get a new crane that could move it faster, because that velocity will have a squared effect on whatever the kinetic energy is, which can cause more damage in the end. If you're still confused, watch this video again. If you're still confused after that, go ahead and shoot me an email. I want to know where you're getting stumped so that I can improve this class and make sure that you understand it.